Okay, hope you enjoyed the little introduction. That was a song from the great guitarist Chet Atkins called El Vaquero. So what I'm going to look at is, we're going to do this video in several parts. We're going to look at, the first thing is the limit laws and run through how these work. These things work pretty similar to the way order of operations in arithmetic works. So this is a series of laws that we have for limits. And the idea is, the first one we have the sum law, and that just says if you have a limit as x goes to a, f of x plus g of x, two functions added, then you split it up into two limits. You do the limit of the first function plus the limit of the second function, and then of course you just add the result of each limit. The difference law is basically the same thing. If you have a limit of f of x minus g of x, that's the same as limit f of x minus limit g of x. So you're breaking it up into the two limits, getting the two answers to the limits L and M, and then subtracting them. Right? And the next one is the constant multiple law for limits. So this says basically if you have a constant multiplied by a function, C represents just some number. It can be any number except 0. And basically what happens is you just pull it out. Okay, so you can take that constant that's multiplied, bring it outside the limit, and then multiply that by the limit of f of x. Right? That's how you get that. Then we have the product and quotient rule are very similar. This product law for limits just means if you have a limit of a product, two functions, then you do the limit of the first function multiplied by the limit of the second function. Quotient law, same idea. If you have a limit of a quotient, f of x over g of x, you just do the limit of the numerator, and then you do the limit of the denominator, then you divide it. Okay, and then the next two go together, the power and root laws, and these go like this. If you had a limit of a function to a power, well, you can actually do the limit of the function first, then take it to that n power. And the root law works the same way. If you're doing a limit of a root, and it can be any root, a square root, a cube root, whatever, of a function, well, you can do the limit of the function, then you can take the root, like that. So I'm just going to demonstrate these ideas of each one of these things. So let's look at the sum law. You have, say you have the limit ln x plus e of x. Now we're not going to work out the limits. We're just going to simply break this up. So we would break this up. We would say the limit x goes to 1 of the first function, ln of x, and then we would say plus the limit x goes to 1 of the second function e of x. Now again, we're not going to work that out. We're not there yet. We just want to learn how to break these things up. Okay, the difference law. Okay, notice I have two functions being subtracted, so I can break this up. The first limit would be the limit x goes to pi over 2 of the sine x, and then minus, and then the second limit would be the limit x goes to pi over 2 of cosine x. So 1 and 2 both work basically the same way. All right, the constant multiple law. So we have a constant, pi as a constant, so that can be brought out. If you have a constant times a function, then the constant can be brought out. Then you can multiply that by the limit x goes to 0 tangent x. That's how you break that up. Okay, let's see. The product law works like this. And this would be, we have two functions multiplied. X is the first function, e to the x is the second function. So we just write that as the limit x goes to -1 of the first function x, and then multiply by the limit of the second function, e to the x, like that. Okay? Now, I think I may have these things kind of backwards. This one is the power law on this number 5, and this one right here would be the quotient law, so I didn't type those correctly, it looks like. All right, so what you would do in this case, what you do is you do the limit as x goes to -3 of x, then you raise the whole thing to the 4th power. Okay, and the quotient law, we have a limit of a fraction, so we just do the limit of the numerator. And then we divide by the limit of the denominator. So you're breaking this up into two limits. Okay, and again, we're not going to work those out. We're just getting comfortable with how to use these laws. Okay, the root law, this is a fourth root. So this breaks up like this. You just do the limit as x goes to 0 of what's under the radical e to the x. Then you take the fourth root of the whole thing. All right, so that would be how that works out. You want to make sure that you can take a limit, of a sum, difference, of products, quotients, roots, and powers, and use these laws to break those up. All right, so the next page, we're going to go ahead and work these out together. And what we're doing on this one is, see, I'm actually giving you three different limits. I'm giving you the limit of f of x approaches 1 is equal to 8. Then I'm giving you a limit of a different function g of x, as x goes to 1 is 3. And then I'm given a third function h of x. The limit of h of x as x goes to 1 is equal to 2. Those are all two-sided limits. All right, so what we're going to do is I've kind of written down the basic steps on here that we want to go through, and you might want to write down what law these are. So this would be the constant multiple law. And anytime that you see this, if you have a number, a constant multiplied by a function, then that comes out. So that's what I did is I brought the 4 out, then I'm going to multiply by the limit as x goes to 1 of f of x. Okay, well notice that I know what that limit is. That limit of f of x is equal to 8. So I'm just going to have 4 times 8. So that's going to be equal to 32. Okay. The next one would be the quotient law for limits. So notice what I did is I did the limit of the numerator f of x divided by the limit of the denominator h of x. Okay, and if you look at this, well, the limit of f of x was given as 8. The limit of h of x was given as 2. So I'm just doing 8 over 2. So that would be equal to 4. That's how that goes. Okay, and then the next example is a little bit more involved on these next couple of examples. But the way these things are broken up is like this. I'm using several properties here. First thing I'm really using is the sum law. So, or the difference law, I guess. Sum and difference are really kind of the same thing, so I'll write that as the difference law. Okay, and you can see that what I did is I broke it up into two limits, the 2f of x and then the 3 at g of x. Then I brought out the constants. So I used the constant multiple rule. So I did that, and then once I've done that, I can take the limits that I gave you, then we can work out the arithmetic. So if you go back to kind of the top of the page, you should see that the limit of f of x is equal to 8, so we have 2 times 8, and then the limit of g of x is equal to 3. So we're just doing 16 minus 9, so that's equal to 7. Okay? And then the next one, we're doing this expression, so we're going to use the quotient law to begin with. So what I'm going to do on that, notice that I just did the limit of the numerator, f of x, g of x, then divided by the limit of the denominator. That's showing the quotient law. And then I'm going to show the product law. And when I do the product law, notice that I break up that numerator into limit of f of x times limit of g of x like that. Okay, that's as far as I can break it up. And then I'm ready to just go through and get everything. Limit of f of x is 8. The limit of g of x is 3. And that's all over limit of h of x, which is 2. So that is 24 over 2. So that is equal to 12. Okay? So that's how we get the answers to those problems using the laws. And this is just something you want to get used to because this will show up throughout calculus with when we learn about derivatives and also when we learn about integrals. These laws are very fundamental to those concepts. Okay, one last example. And this one I'm using several laws. I'm first of all using the root law. So notice what I did is I'm just doing the third root of the limit, and underneath that I'm really using the sum law at the same time. So I kind of combined some rules here. So I've got the limit of f of x, g of x, then plus the limit of 3. All right, now I can work all these things out now. So I've got the cube root, and what we have here is the limit of f of x. Going back to the top of the page, that was 8. The limit of g of x was 3. And then you get this, the limit of 3 as x goes to 1, well, that's equal to 3. I didn't give that to you because I don't have to. So anytime you do a limit of a constant, and x can go to any value, it's just equal to that constant. So this would go like this. So I would end up having the third root of 24 plus 3. That's equal to the third root of 27. So that's equal to 3. Okay, so that's how that could be broken up. So what I usually find students do is students usually have no trouble whatsoever doing the arithmetic, because the arithmetic, you're following order of operations. But what you want to try to get comfortable with is writing these limit steps down, because I want you to be comfortable with these laws and how you can break up limits. Okay, so next thing I'm going to do is we're going to go to the next page, and then I'm going to have you try to work out these 3 problems right here. So what you can do is you can go ahead and pause the video, and then you can go ahead and as soon as you're done, resume the video and check your answers. Okay? Okay, so here is the answers that you should have got. Now I tried to be really careful in how I write the limit laws out. So you want to see how this is done. You want to try to do this step by step. The first one I would have got 8. The second one, 125. Then the third one, there might be a little bit of issues with algebra on this possibly. I ended up getting 12 times the square root of 2. All right, so you want to kind of look at this part right here. I had 3 times 2 times square root of 8. But the square root of 8 can be broken down like that into square root of 4 times 2. Square root of 4 is 2, so you get 6 times 2 or 12 radical 2. Okay, so we're going to move on from there. You can pause the video if you need to and correct things if you didn't get those right. Otherwise, we're going to move on, and we're going to do 2 more types of functions on this part of the video. Okay, so moving down to the bottom of the page, what I'm going to do next is we're going to look at a polynomial function. And a polynomial function you generally learn about in pre-calculus and college algebra classes. It's composed of sums and differences of whole number powers of x. So a whole number is just a number like a counting number starting with 0. So you got no negative numbers, just 1, 2, 3, 4 like you count on your fingers, but starting with 0. So here's 2 examples of a polynomial. I'm just going to say f of x. When you create a polynomial, you're usually just taking different powers of x. As long as they're whole numbers, you're okay. And then you just add or subtract them however you want to. And you can also put a number in front of anything. Okay, you don't have to. So that is a polynomial function right there. Another example would be something like this. We could have x to the 7th plus x to the 15th. And then I'll say minus, and then I'll just put a constant there. Now, the reason why that's polynomial is I do have whole number powers of x, but this is understood to be x to the 0. Remember, x to the 0 is 1. So if you have a constant, that power of x is understood to be 0. So they're just sums and differences, whole number powers of x is what those things are then. Okay, so on the next page, I'm going to go ahead and talk through this example right here. And this is kind of the idea of why limit laws are useful. So this is a polynomial function. You can see I have the whole number powers of x, including that 2x to the 0, just adding them together. So this is a polynomial function. And we learned that we have the sum law. And so what we have here is I just broke this up into the limit of 7x to the third plus the limit of 3x to the second. Now I could have broken this up into limit of 4x plus limit of 2. I decided to just do it this way and leave that alone like that. We also learned that we have the constant multiple. And notice I brought the 7 out, I brought the 3 out, and I didn't do anything here because this is a linear function, and linear functions work the same way that polynomial functions do. So what I can do now is we now got the kind of the power law. So the x to the third, I'm writing that as limit of x to the third. The limit of x squared, I write that as limit of x, then to the second power. Now what I do now is I can now just plug in that a, then I'll get my result. So when I do this, I would get 7a to the third plus 3a to the second plus, and then 4a plus 2. So what this is showing you is based on these limit laws, you can basically just plug in. If you see that you have a polynomial function, then you can just plug that value that x is approaching to get the value of your limit. You don't have to graph it or do anything like that. So thanks to those rules, that's what we can do then. Okay? All right. I'm going to pull up a app. Okay, so here is a Desmos applet. And this just really demonstrates what polynomial functions basically look like. And I like this because you can kind of zoom in on it and stretch and shrink and that kind of thing like that. So here is a limit, right? This is a polynomial, x to the fourth minus 4x to the third, like that and so forth. So polynomial functions always have a certain look to them. And it depends. If the highest power is even, they tend to swing upward. If I put a negative number in front of that power, then what tends to happen is they tend to swing down. Okay, so you can kind of see how this thing goes. The thing is just turned down now. Okay, now if I take that negative out, then it will go back to turning up like that. Okay, if I want to take that off now, and I'm going to take that off, now I'm going to make the highest power a third power. So if your highest power is odd, one side, as x goes to the right, the function goes up. As x goes to the left, the function goes down. That would be if the number in front is positive. And then if I change that to a negative 4, look what happens. Okay, then everything just reflects. So notice the 4 positive. Now if I put like a negative number, I'll put like say -2, then it just does that. Okay, so those are things generally you learn in college algebra pre-calc. It's really nice to know just what the rough graph looks like of these things. Okay, so next thing I've got here is we're going to go ahead and just evaluate some polynomial functions. And the way you do this is it's real simple. It turns out that all you have to do is just evaluate the polynomial. So you don't have to graph, just plug in. You would find if you graphed this polynomial, since it's an odd power, you'd probably find the graph kind of looking something like that on your graphing calculator. So this is a polynomial function because it is sums and differences of whole number powers of x. And then you just plug the 1 in. So we just do 2 times 1 to the third minus 3 times 1 to the second plus 4 times 1 plus 5. So that will be 2 times 1 minus 3 times 1 plus 4 plus 5. So that looks like that is 2 minus 3. Let me erase this little function here. 2 minus 3 plus 4 plus 5. So that would be 9 minus 1. That would be 8. Okay, so that's what you would find on that problem. And I am going to do something on my graphing calculator because I do want you to see something on this. Okay, that's kind of nice. So I'm going to take out kind of what I've got here, and I'm going to put in those polynomial functions. So we've got 2x to the third. And I'm going to move that down. We'll put in the minus 3x to the second. And then plus 4x. And plus 5. Okay, now I'm just going to graph this in a standard window. So I'm going to go zoom 6, standard window. Graph kind of looks like that. Well, we're interested in as the limit as x goes to 1. So if I traced at something real close to 1, like we've done before, like if I trace at something real close to 1, notice that I get a y value close to 8. And if I get closer and closer and closer to 1, what's going to happen is that y value is going to get closer to 8. Well, if we trace at 1, we get the 8 anyway. So that's what I'm showing you is it's a polynomial function. The function value will give you the value of the limit. So that's what I want you to see. Okay, next one, same idea. This is a polynomial function. And this one, it's a quadratic. So this one would look like that if you put it on a graphing calculator. So we're approaching -1 from the left. It doesn't matter if it's a left or right-hand limit. You're still going to get the same thing. You just plug it in. So you do 2 minus 3 times -1 plus 4 times -1 to the second. That's equal to 2 plus 3 plus 4 times 1. So that is equal to 2 plus 3 plus 4. So that would be equal to 9, like that. And again, you can put this in the calculator. You can use your calculator to help you understand limits, but if you're doing homework and stuff on a polynomial, you just do arithmetic, okay? But just to show you again, we've got 2 minus 3x, and then plus 4x to the second. And I'll just put that in the standard window, so I'll go zoom 6. So here's my function. Again, I'm interested at -1. So what happens if I just trace at -1, I'm approaching 9. Okay, so the idea is the closer we get to -1, the closer it gets to the function value, and that function value is 9. Okay, so I'm going to let you all do these two problems. Go ahead and pause the video, work these two problems out. You can graph them on your calculator to make sure you're right if you would like to. Okay, so hopefully you've had time to do that, and I'll go ahead and show you what these look like and what answers you should have got. And it's also kind of good to look at these on the graphing calculator. So they're both polynomial functions. This one it doesn't initially look like a polynomial, but if you multiplied that out 5 times, which obviously you wouldn't waste your time doing, well then it would be sums and differences of whole number powers of x. So it is a polynomial. So all I do is just do the arithmetic. You should have got 1, and on the second one you should have got 32. And you can see the graphs, like the graph of number 1 right here. Notice that if I trace at -2, there's the answer to my limit right there. And then the second one, I graph that. If you trace at x equals 2, there's the answer to your limit like that. So it's real easy to check and verify these things with a graphing calculator. Okay, so pause the video if you need to do anything with that. Otherwise, we're going to do one more thing on this portion of the video. We're going to look next at rational functions. Okay, so what we'll be looking at on this part is a rational function is when you just have a ratio of 2 polynomials. Looks like this, and then the denominator can't be equal to 0. Okay, because you'd have a 0 denominator. And then g of x must have a degree greater or equal to 1. So you can't have like a function over 1, then it's not considered a rational function. You have 2 separate polynomial functions, but the denominator has to have a degree of at least 1. All right, and it can't be equal to 0. So let's go with 2 examples of rational functions. Let's say f of x, real simple. All you do is do a ratio. X to the second minus x plus 1 is a polynomial. X to the third plus 1 is a polynomial. So that is a rational function. Second example would be, let's just keep it simple, x to the 7th minus 3x, and then the denominator, you could have just something like x to the 2nd. You can only have one term in your polynomial. Your polynomial can have just one term. All right, so rational functions, think of those as ratios of polynomials. So we're going to look at this limit. The limit as t goes to -2 of 3 over 2t minus 6. So what I'm going to do on this, the first thing I'm going to do is just plug in the -2. We're going to find the function value at -2. So that's 3 over 2 times -2 minus 6. So that's 3 over -4 minus 6. So that's 3 over negative 10. And then I prefer that you write that the negative, it's just a negative fraction, so it's negative 3/10. Okay, so that is the value of the function. Now, if you applied the limit laws, you would use the quotient law. And if you did the quotient law, you would have this. You would have the limit t goes to negative 2 of the numerator divided by the limit t approaches negative 2 of 2t minus 6. Okay, then you could do the sum and the difference law in the denominator, so you'd have limit t approaches negative 2 of 3 all over. And then the bottom, you can break this up into limit 2t, t goes to negative 2 minus 6. And then one more thing, you could do the limit as t goes to negative 2 of 3 over 2 times the limit t goes to negative 2 of t minus the limit of 6. So I'm kind of doing the limit laws like that. And notice what I'm doing on this. If you break these up using the limit laws, the limit of a constant is always that value. So the limit of 3 is 3. Plug in the negative 2 into t, you would have 2 times negative 2. And then the limit of the constant 6 is 6. So you still get 3 over negative 4 minus 6. So you're still getting the same answer. Okay, so the idea is what will happen on a rational function is, just like a polynomial, you can plug the number in, and if you get a finite number, then that's going to be the answer to the limit. The only thing that will happen on rational functions sometimes is you will evaluate the function and it will be undefined, and in that case, there's going to be some different methodologies to working out those limits. So really what we can do is to do a limit of a rational function, again, just plug that value of a in. So just plug it in, like on this, you'd have p of a over q of a, and if you get a finite answer, then that is guaranteed to be the answer to that limit. Okay, but, if it's undefined, we're going to learn a different technique when it's undefined. So we're not going to worry about that so much in this section. Okay, so I'm going to go ahead and do the rational functions. Okay, so this one again is a ratio of polynomials. And again, you don't have to do the limit laws. You just plug the 1 in and calculate. So we're going to do 5 times 1 to the second plus 6 times 1 plus 1 all over 8 times 1 minus 4. So that will be 5 times 1 plus 6 plus 1 all over 8 minus 4. So the numerator is 5 plus 6 plus 1, denominator is 4. So that would be 12 over 4. So the answer to that limit is going to be equal to 3. Okay? All right. Now, on a graphing calculator, the way that this would work is like this. If you went through and graphed this, now if you do a rational function, you got to make sure that that numerator is in a set of parentheses. So it's worth taking the time to do this because sometimes students don't seem like they are cautious about typing this in correctly. Denominator, since it has more than one term, also must be in its own set of parentheses. So if I put that in like that, and if I just standard window, zoom 6, that's what the function looks like. And then if I trace it 1, okay, now the idea on this is if I take a number real close to 1, see what I'm getting real close to 3. And actually, if I just trace it 1, I get 3. So the function value is the answer to that limit then. All right? So that's kind of what I want you to see on that. Okay, all right. The next one would go like this. And again, this is another example of a rational function. So you are allowed to just plug this in. Now, if you plug the 4 in, you're going to have 4 plus 2 over 4 minus 4, so you get 6 over 0, so you're undefined. Now, what happens on this is we're not going to learn how to do this limit in this section, so we can't use this method on this particular problem. We are going to learn that in a different section when we start talking about what we call infinite limits. And again, what will happen on this one, if you graph this function in your graphing calculator, I'll put in the x plus 2 and then divide by, x minus 4. Whoops. Here we go. So x plus 2, x minus 4. And then you're going to have a vertical asymptote. So if I graph this function, you've got a vertical asymptote on this. And if I trace at 4, we're doing the limit as x goes to 4, it's undefined. If you look at your table of values, if you go second graph, at 4 there's an error. Now that doesn't mean the limit is an error. It just means the function's undefined, and we're going to learn how to evaluate that limit in a future section. So the idea is this had a vertical asymptote, and what's happening is the right-hand limit seems to be going to infinity, and the left-hand limit seems to be going to negative infinity. So we'll talk about that in a later section. Okay, so the last thing I want to do on this video is I'm going to have you pause this and work these problems out, if you would. And you can graph them on your calculator if you'd like to. And then we'll go over those, and then that'll be the first part of the section in the video. Okay, so just a coincidence, we got the same answer on both problems. These are both rational functions. And so I do the arithmetic, and you would have got negative 1/5 on both of those. The graphs reflect that. The graph of x plus 1 over x squared plus 1, if x is negative 2, y is negative 0.2, and negative 0.2 is the same as negative 1/5. So you can see that graph on both of those. Okay, so that will wrap up this part of the video. Hope this helps you to understand limit laws and polynomials and rational functions. So good luck. Let me know if you have questions.